Hi everybody, in this video we're going to talk about area. This video is actually going to be a review video for all of Module 4. I think we can knock out a lot of the important topics in it all at once. So bear with me a little bit while I talk about some of the things that you need to know about area. First of all, what is area? The way to think about it is that area is the amount of space that a flat object takes up. So, I'm going to draw a rectangle. And we've looked at rectangles a lot because understanding the area of a rectangle is one of the most important things that we will learn in third grade math. It's something that's going to help us throughout our math careers. So I've drawn a rectangle as best as I can. It's not quite straight, but it's okay. And if I thought about this as an array, which I will for a moment here, I'm going to use blue to highlight the portions of it that show the array. If we look at it in this way, we notice that this is an array that is 3 rows of 4. There are 4 in each. And when we think back to our work with multiplication, we notice right away that 3 rows of 4, we can solve for the amount of objects in the array by using multiplication. And that's 3 times 4, which equals 12. The only difference here is that when we talk about the area, what we're saying is that this isn't just any old number 12. This is 12 square units. And depending on the size of the measurements that we're taking, it'll be different square units. So if these were centimeter squares, it'd be 12 square centimeters. And if it was 12 square inches, it would be if it was inch squares, it'd be 12 square inches. And the difference between the two is that because centimeters are smaller, 12 square inches is a smaller area than 12 square centimeters. Let me start that over. 12 square centimeters is a much smaller area than 12 square inches. The bigger the measurement, the bigger the area. So if this was 3 miles high, and this was 4 miles wide, we'd be talking about a huge area that you'd have to drive across or walk all afternoon. If it was not 3 miles and 4 miles, but say 3 meters and 4 meters, well, that's about the size of a small room, maybe a kitchen. And if it was centimeters, then you could fit this square easily in the palm of your hand. And even though they both all have 12 square units, they're very different sizes. So here, instead of calling it 12 square units, we would call it 12 square, and we're going to write SQ for square, centimeters. Okay, so let's continue on here, but I'm going to change something. What if I got rid of the array inside? I'm going to redraw the parts I accidentally erased. I didn't change the size or dimensions of the rectangle. I just got rid of the array. It's still 3 units high and 4 units wide, and we're saying that these are centimeter units. I can still use 3 times 4 equals 12. Even though I don't see the array, I can imagine that it's still there. It's 3 units high, 4 units wide. I can imagine that it's 3 rows with 4 in each. That's still pretty easy to see because I still have that grid paper there. Let's try a slightly more challenging example. I've drawn a similar looking rectangle, but there's no grid paper. So I don't know yet how many units high and how many units wide it is. I need more information, so I'm going to help you out. I'm going to say that, hey, look, it's again 3 centimeters high by 4 centimeters wide. I have no grid paper, but it's really the same problem as this one. I can imagine that it's there. I can imagine that there are 3 centimeter units going up and that there are 4 units in each row. And I know that not because I'm eyeballing it, but because that's what the problem is telling me, that I've created a 3 centimeter by 4 centimeter square. And even though I don't have the grid paper in front of me anymore, I can now use multiplication to solve the problem. Because I know that the area of any rectangle, just like this one back here, can be thought of as an array. And to find out how many objects are in the array, I can multiply the number of rows by the number of objects in each row. Or when we talk about an area, we say that we're multiplying the side lengths. So I'm multiplying 3 centimeters by 4 centimeters. So, and I know that 3 times 4 equals 12. And because it's a unit of area, I'm going to say that I have 12 square centimeters. And it's really the same problem as here. I'm just imagining the array completely, without the assistance of grid paper. I can take this problem and I can apply it to any area problem. I can take this principle, rather, and apply it to any area problem. All I need to know is the side lengths of the rectangle. Let's say I said that this is 5 meters on that side and 7 meters on that side. Well, what I've learned is that to find the area, I need to multiply the side lengths. So I have a 5 meter side length times a 7 meter side length. And I know that 5 times 7 is 35, so it's 35 square meters. It's really not very challenging to find the area of a rectangle, as long as you recall that we can think of it as a rectangular array, like arrays we've looked at throughout multiplication. And that means all we need to do is either we could actually construct that array. I could start saying, well, I know that there's 5 rows and there's 7 in each, and I could build out my array like so. That gets pretty time-consuming, though. I don't want to actually do that, so I'm using the shortcut of multiplication. I don't want to count the 35 circles up or build a grid array. So I know that I can multiply. It's the whole point of multiplication, to make this addition and counting much faster. And say that I know there's 7 in each, and there's 5 rows. So instead of drawing this, I have the luxury of just using my knowledge of multiplication to say 5 times 7 equals 35. Additionally, our knowledge of multiplication allows us to do some pretty fancy things. One of the final things that we looked at in this topic is, what if we have more than one rectangle? What if I have a rectangle that looks like this, and it's stacked up to one that looks like this? And I'm asked, how much does the figure have altogether? It's really just 2 rectangles, rectangle 1, rectangle 2. Before adding in the numbers, let's think about what the problem is going to look like. I'm going to call this rectangle B, and I'm going to call this rectangle C. So the area of the 2 of them is going to be the area of B added to the area of C. And that's going to equal the total area. Alright, now what I can do is start plugging in some numbers here. Let's say that this rectangle, I'm just going to say square units for now, is 2 units high and 5 units wide. And then this one is 3 units wide, and let's say 7 units high. So the area of B, I'm going to come back down here and I'm going to try to solve the problem. The area of B would be 2 times 5, because that's the side lengths, 2 and 5, and I'm multiplying them, I'm imagining that array. And then what I'm going to be doing is I'm going to be adding it to the area of C, and that's going to be 3 times 7. I could do these separately. I just like writing it out using the parentheses as one equation. That's just going to let me go a little faster here. And so then I can say that the area is, well, 2 times 5 is 10, plus, well, what's 3 times 7? 3 times 7 is 21. And you're starting to see the reason to try to memorize all of these multiplication facts. It's just going to speed you up on these kinds of problems where you have to use them. And 10 plus 21 is 31, and it's 31 square units in area for the whole figure. That's the 2 rectangles put together. That one's fairly easy to see, and there's an even more exciting problem type that we can solve. One where we have a missing area. So I'm going to draw out a nice rectangle here, and then I'm going to draw a rectangle inside. And what this problem is going to ask me, it's not going to ask me the two put together, because one is inside the other. There's going to be a shaded part. I'm going to shade that part in red. And it's going to ask me, what is the area of the shaded part? So it's a big rectangle with a part missing. And anytime we see something being taken away or missing, we should be thinking about subtraction. So we have what I'm going to call, maybe what I'll do is I'll shade this one in green, and that'll give us a language to talk about it. So it's going to ask us, what is the area of the rectangle, of the red rectangle? So I'm going to say area red. And right now that's unknown. That's what the question is going to ask us here. And I'm going to solve for that by, well, the first thing to notice is to look and see we have this big outer rectangle. I'm going to call that the black rectangle because I outlined, well, no, I shouldn't call it that. I outlined the middle one in black as well. I'm going to just write outer rectangle. So that equals the outer rectangle, but it's missing a part. It's missing the green rectangle. I'm going to say rect for rectangle. So it's the outer rectangle minus the green rectangle, because that's the part that's being taken away. And then it looks like any other area problem. Let's say that the red rectangle, the black rectangle, sorry, the outer rectangle is 3 by 5. And let's say that the inner one, let's make our life easy here, is 1 by 2. So the outer one is 3 times 5. The green one, the inner one, is 1 times 2 to solve for the area. So 3 times 5 is 15 minus 2, 1 times 2. And that will equal 13 square units. What makes this tricky is that thinking step of noticing that when you take part of the rectangle away, this inner part, when it's cut out or something like that, that we're using subtraction. If you see two rectangles added together, like this one, you should be thinking addition. If you see two rectangles where one is inside the other, you should be thinking about a subtraction problem, because it's going to ask you how much is left. You're going to see problems like this in 3rd, 4th, and 5th grade. A lot in 5th. And it's often going to be embedded into word problems. Maybe here we might have two garden beds next to each other, and how much area are they taking up together? Here it might be a picture frame, and you have the board part of it, and you have the actual picture inside, and what's the area that surrounds the picture. You'll see it in lots of different ways. It could be a wall with a window in it. It could be a table on a floor. There's lots of ways for these problems to occur. And just to bring us back around to what is the absolute takeaway here? What is it that you need to know? Well, when you see a rectangle, to find the area. And the area is the amount of space that the rectangle takes up. All you have to do is multiply the side lengths. So, for example, let's do just an easy example here. Let's say this is 8 and this is 4. The area of this rectangle would be 4 times 8. So the area is 32 square units. If you can memorize that the area of a rectangle can be found easily by multiplying the side lengths, you're in great shape. To really master area, you need to be looking for these two kinds of area problems. One where you add two together, and guess what? You use addition if you're adding two together. Or one where you're taking one area away, and in that you use subtraction. If you can master the basics and master these two problems, you will be doing great in area. And it's such an important topic. I thank you for watching this video. I hope it has been helpful, and please feel free to ask me any questions.